Hey guys, and welcome to a brand new week of Sliceform CAD, where today we're going to be working on parametric design. Now, parametric design is another one of those ways to categorize 3D modeling. Some people, they actually use it as a kind of a sculpting tool if you're working on animation or CGI or video game character development. You think of 3D modeling a little bit more like sculpting clay and less like, hey, I need this bolt to be exactly 25 millimeters, or hey, this part has to be exactly this size so it can fit inside this section, or whatever it may be. But parametric design works within parameters. And parameters is basically any dimension or angle or quantity, any value that you can give to CAD that you can then change and tweak along the timeline. So for us, a really good example is if I was working on some metalworking parts and I made the entire thing, and then I was at the very last step and I said, oh no, that hole that was supposed to be at the very beginning was supposed to be 2 millimeters, not 3 millimeters. Do I have to remake my entire model? No, that would be a nightmare. You can roll back the clock, edit that, and because it's a parameter that isn't driven by anything else, you can then zoom forward to the present, and then that change will be changed all the way along your design. Now, parameters in CAD design may just be dimensions and quantities, but in the larger scope of CAD modeling and, well, engineering as a principle, because we can use this CAD software for different thermal problems, different simulations where they need drop tests and stuff, we can also include different values for things like viscosity, luminance, any other quantities that you can possibly imagine that can be derived for a physical object. You can put it inside a parametric design. For our project for today, we are going to be making a M5 by 25 bolt. This is actually a part that I use all the time on my 3D printers. It's what joins a lot of the features on an Ender 3. And very often when I'm working on a new project that I need to screw certain parts together, I'll be using bolts all the time, and we'll be using them in projects to come. But do I have to model a brand new bolt for every single project that I need, even if the diameter or the length changes? No. Parameters. You don't have to make brand new parts over and over and over again. You can just save it, and if you put in some clever parameters that are very easy to understand, very easy to change, then you can make a brand new part, export it, make another part, export it for this project, over and over and over again for whatever need that you have. So with this M520 bolt, this is going to be within our millimeters. And so for any project that we have where you have metric bolts, this can go in between it. If you'd like to go ahead and make this same project but for imperial bolts, absolutely go ahead and do it. But we are going to be starting off by verifying that our units are in millimeters right here. Anytime I'm working on a metric project, just keep it in millimeters the whole way through. If I'm working on a metalworking project where I know the tools that are in America are very likely built with imperial measurements in mind, then I'll switch to inches. But most of the time I'm working in millimeters. So we're going to be starting off by introducing a new concept called components. So very often if I'm making a part and I make a 3D body, it shows up under here as bodies and then sketches. But this top file right here, this is my component, and it's signified by a little white box, whereas the body is signified as a white cylinder. The difference is that a component is the entire file. It includes any bodies, sketches, appearances, construction lines. Anything that you need is all in this one file. So if you make an assembly where multiple parts are being joined together, you don't lose any of that information. It's all combined. So we can start off by making a component, because this is something where you're not going to do much with a bolt, but you can bring it into an assembly where that's going to be really useful. This new component, we're going to make it as an external. We'll be going over what external and internal components are when we get into the assembly section, but for now, just know that the external makes a singular file, and you can click and drag this into any other files you need. So we're going to name this an M5 by 25 bolt. So we're going to go ahead and click OK, and as soon as I do this, you can see that my whole screen has got this little blue box around it. And I do have my component right here, but I also have this really funky shape up here. It looks like a bunch of blocks together. This is the larger sub-assembly component. So right here is exactly what I'm going to be working with, and if I need to add any parts to this or export this outwards, I can do that just fine. Now I can start to put in all of my parameters. So we're going to go into Modify, and then Change Parameters, and we'll have this little pop-up box where we can add in as many parameters as possible. So if I start to just make a project just kind of randomly, every single dimension that I use is going to be filled up in the section where it says model parameters. We haven't made anything yet, so it's totally blank. But we want to be able to put in some parameters. So when it comes time to say, hey, what is the length of the thread? Instead of typing out 25, enter, and then anytime I need a new bolt, I have to go searching in for that sketch and retype it. I can just make a parameter called thread length, and then I can just go into this box, type 25, and it's very obvious what that number represents. So when I go into my dimensioning, I just type in T for thread, and it will automatically pop up and say, yep, you probably want this one, and then it puts it in place. It is very, very similar to what we did in the very first episode, where we actually use a mathematical relation between two different dimensions. So for us, we are going to be putting in a name, our expression, which is basically what is that dimension, and then clicking OK. And for this bolt, we're going to be using quite a few of them. So our first one is going to be the diameter of the head. And in this name, you can't put any numbers or any spaces. So you can basically type everything out as neatly as possible and put a little underscore underneath it. So our unit is going to be 8.5 millimeters. We can click OK. And there we go. Now we've popped it in there, so we know exactly what the name is and what it means. So go ahead and put in the rest of these that you'll find in your packet, and we can click OK to finish that off. So the last parameter that we'll put in is something called quantity. It is basically if you need to have multiple bolts in there, you don't need to use the rectangular pattern tool, it's already put in place for you. But we don't want for individual bolts, we want to have a unit list. It's just a number. So under the units, as you can see, we have a bunch of different things for forces and powers and magnetism and all kind of stuff that we really don't need. We're looking for this one at the very top that says no units. So we can just click OK, and that's all good to go. Now we can just click OK to get rid of that. Now, as you can imagine, we are going to be making a bolt with a rotation because it is a rotationally symmetric part. So we can go ahead and make a sketch on the very front plane, and using the line tool, starting at the very origin, we can make kind of like a half bolt shape. And then we can finish this off. You'll notice that your left vertical and your bottom horizontal line should be black because they are fully defined. But now we can put in all of our dimensions. So I'm going to start off with the horizontal, and then we'll go to the vertical. So we can click D for dimension. I can click this top bar, and this is going to be the height of the head. So if I click this, click it again, and type in capital H, then it'll give me all of the parameters that I have in here. Well, head height is exactly what I'm looking for, so I can hit enter. You can see it's a little bit smaller. So let's click and drag that down. There we go. And so whatever we put in that function is set right there. This will be the length, so I can type L. Yep, that's exactly what I'm looking for, 25. The reason that the length and the thread length are two different things we'll go into a little bit later. And then for our vertical lines, because these are basically our radius, we can't just type in our values. We need to basically say that this is going to be our head diameter divided by 2, and hit enter. And same thing for the bottom here. This is our bolt diameter divided by 2. Anytime you are searching for a bolt, it is always measured as the diameter, not as the radius, hence the correct nomenclature, I guess. We can say, yeah, let's finish that sketch, and then let's make it a revolve. We only have one profile, so we just want to select the bottom red x-axis, and we've got our bolts. There we go, pretty quick. We do want to be able to put in the little socket head right there. So let's go ahead and make a new sketch on that face, and we want to put in a polygon. So I'm going to click from the very origin, pull outwards. It isn't strictly necessary, but I just want to make this totally horizontally constrained. And then as far as the width, we want to make this the wrench depth. excuse me, the wrench width. There we go. And that's set to 4 millimeters. And then we can just go ahead and extrude that shape. We can say negative wrench depth. There we go. This type of shape, this is not called an Allen key. This is called a hex wrench. Allen key is a brand name, weirdly enough. So this is a hex wrench. That's what you'll see on all of the bolts. Now we can go ahead and put in some threads. So the threading section will be on this area. We do want it to be a modeled thread. The only difference between modeled and unmodeled is that if we click OK, this just puts the decal of a thread on there. So it uses much less data. If you've got a large assembly and you just want this to be the idea of a bolt without actually all the geometry in it, then you can leave it as a decal. But I'm just going to leave it as modeled purely for this class. Because we've set this to be 4.9 millimeters in diameter, which is actually the correct final diameter of a bolt, it said, okay, well, I see you using a metric unit up here. That's about 5 millimeters. Let's make it an M5, which is completely correct. But in here, we already have full length selected. That's not what we want. If we uncheck this, then we actually have a straight shank right here that we can adjust. If you need a bolt in the future that does have its thread only partially up through it, then this is where you can adjust the entire length or just the threaded length. But for us, the length here is going to be the threaded length, which is the exact same as our full length. So you can click OK on that. And just like we did with the geocache hide, we do want to put in a light chamfer all the way around the ingress of this hexagonal hole. So I'm going to make a new sketch, and this is going to be on the right plane. And because our sketch is going to kind of intersect with our whole bolt here, we can just go into the bodies and turn this off. So now let's make a little triangular shape here, and we're going to give it some equal constraints on either side. You can see this vertical line, I can move it left and right, which we don't want. So let's go ahead and constrain it with the origin using the coincident tool. Now we can click D for dimension and give this an edge length of 0.5 millimeters. And then I want to dimension the very top of that point to the origin to be 2.35. And this will give us a fully defined sketch. And this is going to be our profile that we're going to be cutting out the head of our bolt. So let's hit finish sketch. And because when I turn back on my body, this is kind of locked in the frame. It's not super duper easy to click on it. I'm going to keep my body unchecked. I'm going to make a revolve using this profile. When I do this, I want to have it as cut, and then I can put this body back on there and click OK. And now you can see it has cut away the entire top section. Now we also want to do a same feature to the very end of our thread over here. So you may go, oh no, I need to make another sketch and then another revolve. No, we don't. We can always go back into the timeline and double click on that sketch, and then we get back in there. This is the power of parametric design. If you ever make a mistake and you go, oh yeah, I'm done with that, and then you find out, oh no, actually, no, I'm not. You can always roll back the clock, put in any features you want, and then the rest of your file should be okay. So let's put in another triangle. So let's go ahead and make this just like the other one, where we're basically enacting what a metal lathe would do anyway. We have a cutter at 45-degree angles, our bolt would be spinning, and we would just move that cutter into it, and it would remove the outer thread of it. Again, we want it to have an equal length here, and this also wants to be 0.5 millimeters. So I may as well click an edge over here, go back over there, and click that as well. The fewer dimensions that you have on a design like this, usually the better. So I want to dimension this so this vertical line lines up with the very edge of there, and I can do this again with my parametric design. So I can click D, and I can click the very outer edge of that triangle, my origin, and conveniently, this is the length of my bolt plus the head height. And as soon as I do this, it'll line it up nice and neat. So no matter if I change the length of my part or any other feature about it, it's always going to be holding in that same dimension. I can do the same thing for this bolt here, where I say, yep, that's my top point, that's my origin, and again, that is my bolt diameter divided by 2. So if my bolt changes, this will change with it. Then again, I can hit Finish Sketch, but this revolution only took into account that cutout. So let's go back and add that second profile. So I'm going to click that again, and it's in fact cut it out. Ooh, but as we look at this, it does actually cut out this little sliver. It leaves us with this annoying little feature. So what we can do is go back and actually extend the boundary of what that thread would be, or the profile of what that thread would be. So I'm going to double click the sketch again, and just using my line tool, I'm actually going to click on either point and make this big boundary that goes around it. It doesn't need to be neat. I actually don't care about the dimensions this much. It's just to say that, hey, I'm not only cutting this, but I'm also cutting this outer size as well. So let's say Finish Sketch, go back into my Revolve and click that as well. And now we don't have any floating geometry hanging out. So if you ever have any kind of straggly bits of data where you're like, you're not supposed to be there, you can just kind of play around with your profile, how much you're cutting out, because that's exactly what you do on the metal lathe. You would say, hey, I haven't taken off enough material, so I'm going to take off another pass or go a deeper pass. And that's looking pretty good as far as the ingress of both our thread and for our hex key. Some of the final features that I do want to put on is that we do have some sharp corners there and there. In manufacturing, sharp corners are a disaster, so I'm going to use the chamfer tool to kind of knock these down. I'm going to give this a 0.5mm chamfer on either end, and I can see it's a little bit more realistic. But now I also have a knurl that goes all the way around the head of my bolt. It isn't a diamond knurl like we did in the geocache hide, but it's just a normal straight knurl. It's just a little bit of cut in so that you can actually have a grip and screw it in by hand. So in a very similar way, we're going to be making a cutout and then making a revolution all the way around. This is still just a model for any projects that you have. So if we were to put in like 100 cutout in there, that's a ton of data. And then when you pull this bolt that already has an unnecessary amount of data into your project, you go, hey, why is my computer lagging? And it's because you put in unnecessary information into it. So we're just going to put in a few amounts of knurls in there just so the user can kind of get a feel of what it's supposed to look like. So to make my knurl, I'm going to be making a sketch on the very top of my bolt, and I just need to make a simple triangular cutout. So using the line tool, I'm going to be making just a general shape of a triangle. I can always highlight it and give it an equal constraint. And then I'm going to be giving it a horizontal and vertical constraint between the bottom of the triangle and my origin. So now it can't move left and right. I can only kind of change the size of my triangle and like how large it is. As far as a width of this, or size of my triangle, we can just dimension it to be 0.1 millimeters. And as soon as I do this, you can see it is pretty tiny. So let's bring it all the way down and zoom in just a little bit. So I want to make the very top of this triangle tangent with this outer ridge. So that requires a tangent constraint. Let's click that, and there you go. Now my triangle is going to be perfectly cutting all the way through. So let's go Finish Sketch and then Extrusion. So I'm going to select my profile and the extent, because this may change based on the size of my bolt head, I'm going to try and use the geometry as my starting point and my end point. So my extent is going to be to the object, and I'm going to be clicking the underside of the bolt. That way, if I know, hey, later down the line, my bolt head needs to be larger, this extrusion isn't going to stop 5 millimeters. It's going to extend all the way past it so it meets the other geometry. So we can click OK, and as you can see, 0.1 millimeters, it ain't much, but it's enough to kind of say, yeah, this is a knurl. And you go, okay, cool. Then we can go ahead and add a pattern. This is going to be a circular pattern. My type is going to be in features. You could also click faces and then select these inner pieces, but very often having features as the default is much easier. And we're going to go ahead and click the most recent extrusion on our timeline. Our axis, because we built it right in the middle, is going to be our x-axis, that's the red one. And we want 40 of these knurls all the way around. Now we can click OK. And because you'll probably want multiple bolts in your project, not just one, we're going to make this into 4 different bolts within this file. So let's go ahead and go into Create, Pattern, Rectangular Pattern. And then under my type, I want to select bodies, because I just want to have this body be multiplied essentially. My direction, I can have it as my z-axis, just so it's a little easier to see. And my quantity, this is where we can type in quantity from our parametric design. I don't care about having any other dimensions. And then we can pull this arrow out to define exactly how far away. We don't really need any spacing in specific, just as long as they've got some clearance to it. And click OK. And then finally, we're going to click this little green arrow where it says Finish Editing in Place, and now our file is completely done. So if you have any projects where you need any bolts of any kind, this is where you can then go into it, edit your parameters, and then put it into your design. As an extra challenge, if you want to save this file and then go ahead and make some parametric files for any nuts or bolts or threaded inserts, now's the time to do it.